Welcome to solverfy.
Okay, so for this problem, you have a big loop, small loop inside it. This big loop has a radius r equals 1, and this small loop has an area of 2 centimeters squared equals 2 times 10 to the minus 4 meters squared. And you're asked, basically the ultimate goal is to find the EMF induced in the loop as you change the current through the outer loop uh, linearly with respect to time. So first you're asked to find the magnetic field at the center of this loop due to this larger loop. And so the magnetic field in a loop of wire is generally given by mu naught I over 2r. For some reason, I find that very easy to remember. And R is 1, 2, and then I original is 20 amps, and then I final is negative 20 amps. It's kind of weird to use negative currents, but it changes its direction. So I guess we can I guess it's fine. So yeah, so we just kind of need to plug in 20 mu naught and then 2 times 1 for A to get the magnetic field at time equals 0. And for that, I got 0.000126 Tesla. And then it asks for the field at half a second. So after half a second, the magnetic field is 0 because it's halfway and it's transitioned from 20 to minus 20. So if the current's 0, at that instant, there's no magnetic field created by the larger loop. And then it asks for what the field is after 1 second. So that's when it's completed its cycle. And so that's minus 0.0000126 Tesla. So it's just reversed its direction. And then question part D asks, I just wrote down yes in my book. What does it ask? From 2, 0 to 1 is B reversed. Yes. Because the inner loop is small, assume the B is uniform over its area. What EMF is produced at half second? So this is a nice example because at half second, despite the fact that there's no magnetic field, there is an induced EMF because the magnetic field is changing. So it's only 0 magnetic field for an instant in time. And so we can use the usual Faraday's law to get the induced EMF. And so I'm not going to worry about the sign. So let's just say magnitude and just cut this plus, and we can figure out the direction. I don't even think we need the direction for this problem. The area stays the same, not bending or changing the loop, but the B field is changing. So it's the derivative of the B field with respect to time. And so that's A times the change in B over the change in time. This delta time is 1 second, so I'll go ahead and put that over in our given section. How many sig figs are in this problem? 3 sig figs. Oh, whoops, I just read that this was 200 amps and not 20. So actually, let me go and make sure my numbers are correct otherwise. So forgive me as I do this. Okay. No. Okay. Cut that. Oh my gosh. 200 amps. And then, yeah, let me just double check how this change has affected my number. I don't remember if I actually put in the right one. Oh, I did actually originally put in 200 when I had my calculations. Okay, wonderful. So actually, yeah, I think all my numbers should then be right. So, okay, back to the problem. So A, change in B over change in T. So the change in B is equal to the original B times 2 because it goes from plus its value to minus its value. So I'm going to call that B naught. So then it's just A, 2A, B naught divided by delta T. And so when I evaluated that, I obtained 5.04 times 10 to the minus 8 volts.